Hello friends, now we have to solve the given differential equation. You can see here the given differential equation is x square y double dash minus x y dash minus 3y equal to x square log x. This differential equation can be also written as x square d2y by dx2 minus x times dy by dx minus 3y equal to x square log x. You know that this is the second order homogeneous linear differential equation. This is homogeneous linear differential equation. So when we solve this homogeneous linear differential equation, first we convert this differential equation into linear differential equation with constant coefficient. So first we put here x equal to e to the power z, x dy by dx equal to capital Dy, and x square d2y by dx2, this is equal to capital D minus 1y. Here this capital D, this is equal to d by dz. Here we put, when we convert this homogeneous linear differential equation into linear differential equation with constant coefficient, always we put x equal to e to the power z, x dy by dx is equal to capital Dy, x square d2y by dx2 is equal to capital D minus 1y, where capital D is equal to d by dz. Now this above equation can be reduced into d minus 1y minus dy. Here we put in place of x square d2y by dx2 we put d minus 1y. In place of x dy by dx we put capital Dy minus 3y is equal to, here in place of x we put e to the power z, this becomes e to the power z square, and when we take log on both sides, so this log x is equal to z here. So in place of log x we put here z. So taking common y in the left hand side, so we get d square minus d minus 3 times y is equal to z e to the power 2z. This is equal to d square minus 2d minus 3 times y z e to the power 2z. You can see here, this is the second order homogeneous linear differential equation, and when we convert this, when we put x equal to e to the power z, x dy by dx is equal to capital Dy, and x square d2y by dx2 is equal to capital D minus 1y, we can see here this is the second order linear differential equation, with constant coefficients. You can see here this is the second order linear differential equation with constant coefficient. So first we convert the given second order homogeneous linear differential equation into second order linear differential equation with constant coefficient. Now we solve this linear differential equation with constant coefficient. So first we form here auxiliary equation. For forming auxiliary equation we replace small m in place of capital D. Now we form auxiliary equation. So auxiliary equation is m square minus 2m minus 3 equal to 0. Now we find the roots of this auxiliary equation. So this can be written as m square minus 3m plus m minus 3 equal to 0. Now taking common m here, we get m minus 3. Taking common 1, m minus 3. When we taking common m minus 3, we get m plus 1 is equal to 0. So m is equal to minus 1 and 3. Now the complementary function can be written as c1 e to the power m1z plus c2 e to the power m2z, where m1 is minus 1 and m2 is 3. So c1 e to the power minus z plus c2 e to the power 3z. This e to the power minus z can be written as c1 upon e to the power z plus c2 e to the power z whole cube. You can see in this problem we replace x by e to the power z. We replace x by e to the power z. So when we convert this e to the power z into x, so this will be c1 upon x plus c2 x cube. This is the complementary function. Now we find the particular integral. For finding particular integral, we write here 1 upon fd, and fd is here d square minus 2d minus 3 times z e to the power 2z. Now we find the particular integral of the right hand side, z e to the power 2z. You know that the formula for particular integral of 1 upon fd of e to the power ax multiplied by v, where v is function of x, we can write this e to the power ax outside the particular integral and 1 upon fd plus a times v, where v is a function of x. This is the formula for finding the particular integral of e to the power ax multiplied by v, where v is the function of x. We replace small a in place of we put d plus a in place of capital D, and taking outside the particular integral e to the power ax. Here we can see when we find the particular integral of e to the power ax multiplied by v, always we take outside e to the power ax and put d plus a in place of d and find the particular integral of v. This is the formula for finding particular integral. Now using this formula, you can see here in place of a, this is 2. So we take outside this term e to the power 2z and put d plus 2 in place of d. Here we solve this, so we get d square plus 4 plus 4d minus 2d minus 4 minus 3z. So this is equal to d square 4d minus 2d, this is 2d, and this 4 cancel out, so this is minus 3z. Now we taking common here minus 3, so we get 1 minus d square plus 2d divided by 3 whole power minus. When we take common minus 3 here in the denominator, we divide the d square plus 2d by minus 3, and there will be 1, and taking it in the numerator, power will be minus 1. Now we expand this by the formula 1 plus x to the power n. This is 1 plus nx plus n minus 1 upon factorial 2 x square and so on. Here when we expand this by this formula, by this expansion, always we take those terms where the power of z and where power of d are similar. So we can take here the power of z is 1, so we take only those terms in which the power of d is 1. So 1 plus nx, n is here minus 1, nx is this minus times 1 by 3, and we take only 2d. Because here the power of z is 1, so we take only those terms in which power of d and z are similar. So this is z. If we take this d square also, d square means this is the second order derivative. When we differentiate this z two times, so the differentiation will be 0. So all the higher order term will be 0. So we take only those terms in which power of z and d are similar. Here the power of z is 1. So we take only this term 2d here. Now minus 1 by 3 e to the power 2z, and this is 1 plus 2 by 3 dz. Now we multiply this z inside the bracket, so we get here z plus 2 by 3 dz. And this dz means we differentiate z with respect to z, we get 1. So this will be minus 1 upon 3 e to the power 2z, z plus 2 by 3. Now you can see here, particular integral is minus 1 by 3 times e to the power 2z and z plus 2 by 3. Now this e to the power 2z can be written as e to the power z whole square z plus 2 by 3. Now we replace x in place of e to the power z. So we get here x square, and in place of z we put here log x. So to the base e. So this is minus 1 by 3 x square 2 by 3 plus ln x. Now the solution is y is equal to complementary function plus particular integral. So complementary function is c1 divided by x plus c2x cube minus x square by 3 2 by 3 plus ln x. So this is the general solution of the given homogeneous linear differential equation. Thank you.